So, Neil deGrasse Tyson wrong about relativity, question mark. And so I seem to have this popularizer of relativity theory in the media. He seems to be making the same sort of mistake as he caught Brian Cox with earlier on another video, and we could really give him the same sort of leeway that it was just loose talking about relativity, hence why he didn't say it properly. So that's why it's a question mark. Is how much leeway are we to give him on his talking about relativity? So the link I'm going to be referring to is this one, entitled Neil deGrasse Tyson on photons and relativity, and then I'm going to go on to this thing, why Professor Brian Cox was wrong, and this is because Neil deGrasse Tyson seems to be caught up in the same problem, and then I'll be referring to Richard Wilson at that site, and so that's where I'm going. So let's get on to the first thing, this video here. That's what we're going to come to, that one. So he's going to give a little talk, let's say. Yep. No, I want it bigger.
I don't understand this question, and you're going to have to take me to school on this one. Summarize the timelessness of a photon.
Oh, beautiful. That is beautiful. Are you ready?
I'm ready.
Are you ready?
I'm ready for this.
No, you're not ready. I don't think
you sound like Beyonce.
I don't think you're ready.
Are you ready for this? Okay.
Are you ready for this?
Tell me, are you ready? I'm ready.
No, you're not.
I'm not ready?
No. Tell me again.
Okay, I'm ready.
All right. You should know, if you study relativity, Einstein's relativity,
right,
that as you increase your speed, time ticks more slowly for you than it does for anyone who's watching you.
Right.
All right. This is the relativity of time. This is well known. We've measured this. This is not. It's not just your clock that's ticking slower. Your metabolism is unfolding more slowly. Your brain synapse is firing more slowly. Everything about you is slowing down. All right. As you travel faster and faster, get closer and closer to the speed of light, you age more and more and more slowly. Time ticks more and more slowly for you.
Okay.
If you hit the speed of light, which we don't know how to do yet, but if you ever hit the speed of light, then time stops. Photons, which is the carrier of light,
right,
exists at the speed of light. It doesn't accelerate from 0 to speed of light in 3.4 seconds.
Correct.
It exists at the speed of light, and because it exists at the speed of light, any watch that it's carrying never ticks. Which means if you are the photon, become the photon. If you are, this is not a proton now, particle in the nucleus of an atom. The photon, the particle of light. If you are a photon and you are emitted from across the universe, you will be absorbed. You will slam into whatever you are destined to hit. As far as you are concerned, instantaneously. That's correct.
Right.
Because no time would have elapsed.
Because no time's correct. Because you can't, because at that speed where you exist, that speed, time has stopped.
It stopped.
So for you, time doesn't exist.
Time does not exist.
Dude, this is mind-blowing.
Time does not exist.
Ah, yo, man.
Okay. Now,
Now, wait a minute. You gotta give me a second, man.
You gotta absorb that.
Nah, that was great.
Now.
Yo, anybody got some weed? I need some weed right now.
Good for you?
That was cool.
Some people would have requested it in advance of this. Let's all move to Colorado and get the weed, right?
Exactly.
So it's why we knew that the neutrino could not be traveling at the speed of light, because the neutrino actually changes species.
So they're talking about the neutrino. There was an experiment done with neutrinos and they suddenly disputed it and they don't agree with it anymore, so that's not part of relevant. So we go back to the beginning bit.
to school on this one. Summarize the timelessness of a photon.
Oh, beautiful. That is beautiful. Are you ready?
I'm ready.
Are you ready?
I'm ready for this.
No, you're not ready. I don't think
You sound like Beyonce.
I don't think you're
Are
ready.
you ready for this? Okay.
Are you ready for this?
Tell me, are you ready? I'm ready.
No, you're not.
I'm not ready?
No, tell me again.
Okay, I'm ready.
All right. You should know, if you study relativity, Einstein's relativity,
Right.
that as you increase your speed, time ticks more slowly for you than it does for anyone who's watching you.
Right.
So, you're saying time ticks more slowly for you than as you increase your speed than for a person observing you, and that's not really quite correct. What really happens is you don't, in your frame, you don't notice time going slower for yourself, so it's a bit unclear whether he's talking about these things properly. So I'm going to refer to this person's talk. This person is Richard Wolfson, Professor of Physics at Middlebury College, and he goes into a lot more details. But really it's a problem of whether Neil here was precise enough, or do we give him a bit of leeway that he didn't get it quite correct or not. So let's go to this talk here by, if I pick it back a bit earlier, I've gone through this talk before in the context of Brian Cox, and it's now seems to be Neil that seems to be trapped a bit by this problem.
Moving clocks run slow. It implies there's something special about motion, special about movement, that there's somebody who's not moving, for whom the clock is right and doesn't run slow, and somebody else for whom, because they're moving, the clock runs slow. Nonsense. Nobody.
So he's saying it's nonsense, and moving clocks run slow is nonsense, and when we get on to Neil, what Neil's saying here, it's not quite clear here what he's saying about moving clocks and so forth. It can be interpreted that he's saying that moving clocks run slow, in which case he's given them a false impression according to Professor Wolfson. So we could give Neil a bit of a leeway that it wasn't quite explained very well by him, but this is the issue. It's bad if you believe in special relativity. It is a bad thing to say that moving clocks run slow.
Between two events is not an absolute quantity. It's something that depends on your point of view. We're going to have to give up the absoluteness of time and soon the absoluteness of space if we accept the simple principle that the laws of physics are the same for all observers in uniform motion.
This is where physics and science fiction collide. Time for the moving clock runs slow.
When you read books about relativity, you will often hear time dilation described by saying, moving clocks run slow. There's two things wrong with that. It's probably grammatically incorrect. It should say slowly. But much more profoundly, it's simply not relativistically correct. And I'd like you to pause right now, turn off your VCR, turn off your cassette player for just a minute, and think about what is wrong with the statement, moving clocks run slow. Why is that statement not relativistically correct? Think about that for a few minutes. When you're done thinking about it, start up again and we'll continue. So what's wrong with the statement, moving clocks run slow? It implies there's something special about motion, special about movement, that there's somebody who's not moving, for whom the clock is right and doesn't run slow, and somebody else for whom, because they're moving, the clock runs slow. Nonsense. Nobody can say, I'm moving and you're not, or you're moving and I'm not. That's the whole point of relativity. Moving clocks run slow is an absurd statement. It's nevertheless used very commonly, including in physics books or books for non-science people about relativity, to describe this phenomenon of time dilation. One problem with the idea of moving clocks run slow is you might imagine yourself in a spacecraft whizzing past Earth with a clock. That's a moving clock, right? And the moving clock runs slow. So you might imagine, in your frame of reference, everything seems to have slowed down. You watch the hands of your clock creeping slowly, having your heartbeat slow. Nonsense. that frame of reference is just as good a frame of reference for doing physics.
And that's a problem with what Neil was talking about. It could be interpreted that's what he was saying, which Wolfson says is nonsense. So,
In as any other frame of reference. Things have to seem perfectly normal in that frame of reference. If they didn't seem perfectly normal in that frame of reference, physics would be somehow different there. And the whole point of relativity is the laws that govern physical reality don't depend on your state of motion.
So that's the issue. So if we go back to Neil, it's sounding a bit, he's given a distorted picture that moving clocks run slow. It's difficult to say whether he really means that, but it's sounding like that's what he's saying. And really, if it's an issue of, if you are an observer and you are observing a clock moving relative to you, then that clock is running slow. But if you are moving with that clock, so it's respect to you, you are not noticing time going slow with that clock. And that's the whole issue there. That is relativity. And whether Neil is distorting it here, it's not quite clear, or what he's saying is not quite clear whether he's got it right.
As you increase your speed, time ticks more slowly for you than it does for anyone who's watching you.
So time ticks more slowly for you as you go faster. So it is sounding like he's getting muddled up there. So we've got him in conflict here with what Professor Wolfson is saying. If we try to give him leeway, he's not saying it quite, Neil's not saying things quite well. So there we go with that issue. These people who are believing their theory of relativity, they should try to talk about things a bit more carefully, because it's leading to conflict between them as to what they believe. They're not being precise enough. Next issue I will deal with is when Neil has asked the question, will Einstein's theory of relativity be disproven? And this is this link here. So moving on, he messed up talking about relativity, and now he's going to defend, Neil's going to defend relativity. We go back to the beginning here. There we go.
Last one for you is from Hugh. Hugh wants to know, could I please ask Dr. Tyson when and if Einstein's theory of relativity will be fully discredited?
It will never be discredited because it works. It's not how theories, you have to understand what it means for something to be a theory.
So, Einstein's relativity will never be discredited, according to Neil. And what we got from here, he didn't really talk about relativity very well here. So it's more than just discrediting Einstein's relativity. It's about people talking about relativity and they're not talking about it very well. So you get one person saying one thing about relativity, another person saying something else, and they're not agreeing. It's contradictory what they're saying. So it's more than just the theory, it's people not talking about relativity properly. So that's that issue. But we also got the problem of when we do actually go to look at Einstein, we find it's not really clear what he talks about. If I go back to, I don't think I've got my web thing up again. Oh, that one. We go back to here. These are my talks I've been putting on. And one of the main ones is, if we take this one for example, Einstein didn't know what he's talking about. Einstein didn't know what he's talking about. There was Edward Teller who went to a lecture by Einstein and discovered that Einstein was given a talk and Einstein didn't know what he was talking about. And so that's a bigger problem with relativity, that it's coming, Einstein's relativity is come from Einstein, and Einstein doesn't know what he's talking about. That should really discredit the theory straight away. It's not just the problem of the people who want to believe in Einstein's relativity, it's also the person who came up with Einstein's relativity. He made a mess of it, so everybody's making a mess of Einstein's relativity. So when it comes to discrediting it, I say that should be good enough.
You have to understand what it means for something to be a theory. There's a lot of misunderstanding about that. If you have a new idea and you want to test it, that's a hypothesis.
But when it's messed up, when you got a theory messed up, when you got Einstein messing it up, and when you got people working from Einstein messing it up, well, it's not proper. You're just going to have messed up experiments as well.
If there's countless objects and phenomena out there that have conduct or behavior that can be brought under one umbrella of understanding, and that umbrella of understanding...
It's not really a proper understanding of Einstein's relativity, it's just messed up.
...allows you to make predictions that are then shown to be true, then...
But it's not really shown to be true. It's messed up. People are talking about Einstein's relativity and they're just messed up. They're just messed up about it. We've got you here giving a talk about Einstein's relativity. Go back to that. And you seem to be in conflict by what Professor Wolfson's talking about. If we're trying to give you leeway, you didn't talk about it very well, but you still messed it up. So as you messed up, theory's messed up. You messed up the theory, messed up the experiment.
Be true, then you have a theory. This is what gives you quantum theory and relativity theory and the theory of...
Well, with quantum, we're not really going on about quantum theory. We're disputing about Einstein's relativity. Will Einstein's theory of relativity be disproven? And I reckon it should be taken to be disproven because it's messed up.
Theory and the theory of evolution and you get all of this. In an earlier day, we didn't call them theories, we called them laws. But it's the same thing. Okay? Same thing.
Sure.
So,
well, I don't think it's the same thing, but we try to move on.
So, if Einstein's theory is ever shown to be wrong, it will not be wrong in any regime in which it has already been tested.
I disagree with that. What you've got is people messing up about Einstein's relativity. So when they're talking about experiments, they're messed up. They're messed up understanding what those experiments are. So it is, I think, is discredited in the experiments which they think supports relativity. It's just a state of confusion between these supposed experts talking about relativity. They didn't understand the theory properly, or we talk about its theories. It's both the special theory of relativity and the general theory. They haven't got their facts right about that theory, and then when they go and look at experiments, they're just messing up.
It would have to be a regime at the extreme limits of how it applies in the universe.
And the limits they're using now, it's already messed up.
And one example of that would be the center of a black hole. We know...
Yeah, it's messed up in the centre of a black hole. I've got Professor Hawking somewhere. Oh, this is a good one. This is Stephen Crothers explains how mainstream is messed up about black holes. You can go on a lot of talks on the internet from him now. Einstein's idiot. Where are we? I must have it somewhere. Think like Einstein. Must have it. I've got Stephen Hawking somewhere. No. Oh yes, there's it. Stephen Hawking. Enlarge that. And it's been reported February 2014, and this is the usually recognised as the expert on one of the big experts on black hole. What Hawking meant when he said there are no black holes. And so we've got this article here. Last week, famed physicist made headlines with his bold statement there are no black holes, and they want to reinterpret what that means. And part of the issue is trying to combine quantum mechanics with Einstein's relativity, and they have lots of difficulties with that. And they also now thinking that the version of black holes they're talking about is wrong. There should be a different thing. When something collapses into a massive, when it's a massive object, and it starts collapsing under its gravity and becomes what they call a black hole, and it's supposed to be described by general relativity, but eventually its general relativity is then said not to actually work anymore, and you sort of like you have the problem at the centre where you have supposed to have a singularity where the laws of physics break down, i.e. the laws of physics as known by general relativity. And so all this waffle about black holes, their current understanding about black holes is probably wrong. As I say, get to see Stephen Crothers for more details about how messed up they are on that. So we get back to Neil again, picking up what he was saying about black holes.
An example of that would be the center of a black hole. We know now that general relativity fails at the center of a black hole. We know in advance of that.
And so that's why Stephen Hawking is saying there's no black holes. What we understand as black holes is wrong. That's probably correct.
We know that general relativity fails at the instant of the Big Bang. This is largely the effort of string theorists to try to come to terms with...
When we go into string theory, it's just a bodge really, trying to fix the mess that Einstein's left us with his relativity theories.
Those very special states of matter and very special times in the history of the cosmos. So it won't be proven wrong because it's already been shown right.
No. He's trying to say it's relativity being shown right. But when you've got all these problems with Einstein, didn't know what he was talking about, and you've got the problem of the people who are following Einstein's relativity, not knowing what they're talking about, you can't say it's been proven right by the experiments we've done. It's just been messed up. It's just an ongoing mess.
And if we find a new idea that takes it to those edges, that'll be a larger circle that we draw.
The existing idea is already messed up. New ideas. One new idea would be you've got the ideas of Einstein and his theories of relativity, and we've already messed them up. Einstein messed them up. Everybody's messed them up.
Around relativity, but what's inside the circle of relativity will remain intact.
Nah. Not when it's been messed up.
That's what it means to be experimentally verified.
Not been experimentally verified. Everything's been messed up. The understanding of Einstein relativity's been messed up. If it's been so radically messed up, then any experiment you've done has been radically messed up as well. No verification. You've just got a mess.
All right, so in short, Hugh should probably not hold his breath for this one to happen.
Exactly.
Neil deGrasse Tyson, Space Chronicles: Facing the Ultimate Frontier is the book.
So there you go. You got Neil prejudiced. He's got too much confidence in Einstein's relativity. He's not taking into account that Einstein's relativity might be really messed up, and that's a possibility. And that's the possibility. I'm saying what's really happened. Einstein's relativity has been really messed up. Einstein messed it up, and other people after him have really messed it up. And when you go to talks by these people who believe in Einstein's relativity, well, they're saying things which other people who believe in relativity don't agree with. They're either saying what you're saying is wrong, or we're saying you didn't say it properly enough. You made a mistake in saying it. It is really messed up.
If you study relativity, Einstein's relativity, right, that as you increase your speed, time ticks more slowly for you than...
Time ticks more slowly for you. If we can get his bit.
Slow down. You watch the hands of your clock creeping slowly, having a heartbeat. Nonsense.
Nonsense. That sums it up. Nonsense. What Neil's saying here, nonsense. He's either not said it very well, or he's got it wrong. It's muddled. It's not very clear what he's talking about. It's nonsense. So when he's talking about, oh, Einstein's relativity can never be proved wrong, well, you've just got a collection of nonsense. Everything is nonsense. You've got a trinormous mess. And you're just showing your prejudice now. You're not considering the possibility that you and everybody else has messed it up so thoroughly. Science is totally messed up now, by Einstein. and you got it defended by people like you that want to keep the mess. We must keep the mess. We want to believe that what we've done is correct. We don't want to consider the possibility that we really effed it up. That is not open-mindedness, Mr. Neil deGrasse Tyson. You're not open-minded. You're not up to the scientific process of testing things. You're not up to it. You just want to keep the mess. You and lots of people like you. That's it. Thank you.